Okay, the following is a video over, this is the course for pre-calculus, and this is a section over solving linear systems graphically. So let's talk about our lesson objectives before we do anything. And we're trying to solve systems of two variable linear equations graphically, okay? We want to classify those systems as dependent, independent, or consistent or inconsistent. That deals with the types of equations and types of solutions we have. And then we want to solve systems of two variable linear inequalities, okay? So let's first talk about what a systems of equations is. Basically, two or more equations that have common variables, all right? So two graphs, okay, two or more graphs, or more graphs. Okay, and then the solution to that system of equations is the point or points that make all equations in a system true, okay? Basically what that means is where do the graphs intersect? Okay, that's the question you ask yourself when you're dealing. And that point, okay, where do the graphs intersect? That's a point. So we're looking for a point. For a point on the graph. And I'm going to label that as an x, y coordinate point. So we will be solving for x and y, all right? So let's kind of think about this in terms of a problem. You've got two different gyms, all right? And not Jim like Jim Smith, but a different gym, okay? You have the healthy gym, which is this line right here. And then you have the workout gym, which is this line here, okay? So it says that the cost of 10 days at the healthy gym, so if we go here to 10 days, 10-day membership, we want to figure out what's the cost. Well, what is the cost? The cost is $25, okay? So this is $25, okay? And what we also notice is that that's the same point as the cost of the workout gym, okay? The workout gym also has a cost of $25, okay? And so that's shown here. The cost for 10 days at a healthy gym is the cost for 10 days at the workout gym, okay? So which of the following is true for the memberships lasting longer than 10 days, okay? What we notice is that, the healthy gym, okay, even though you have this initial cost of $5, the rate at which you pay per day is far greater than the rate at which you pay at the workout gym, okay? So we use these points to say, okay, well, initially if you were going to do this for less than 10 days, then the healthy gym is a better deal. The cost is less, okay? But if you're talking about the workout gym, the cost is more initially, but over time, it's better. So, which is a better deal? We would say that the workout gym is a better deal, okay? So that's the idea. So, but that point there, again, what we're trying to talk about is where do the graphs intersect? What are we looking for? Okay, what we see here is that that's where the two share a common point, okay? So then, okay, what we notice, okay, is this. We have this vocab that says, we have inconsistent, consistent and independent, or consistent and dependent, okay? So what we have here in inconsistent, all right, we have that the lines are parallel. There is no solution. There is no intersection. Okay? Okay? When it says consistent and independent, we know that the lines intersect at one point, exactly one solution. This is what will typically happen. Okay? And then if you have consistent and dependent, that means that you have the exact same line and you have infinitely many solutions. So you're always intersecting. So no intersection. One intersection, and then always intersecting. All right. Okay. The question here says, how many solutions does the system have? Okay. What we're going to do, we're going to go ahead and switch over to Desmos, and we're going to graph this real quick. Okay, so if we look at the graph here, we just went ahead and just graphed these two different lines, and we notice that these two lines are parallel. Okay, these are parallel, which means you have the same slope. Whoops. Okay, and they're not going to intersect. So how many solutions does the system have? We would say none. Okay. Over here, it says, which point approximates the solution to the linear system's graph below? Okay, this point right here, just try and kind of figure that out. It's a little bit more than 1 and a little bit more than 0. Okay, so the x value is a little bit more than 1, so I'm going to get rid of this one and this one. It's closer to 1 than it is to 2, so I'm going to get rid of this one. And the y value is just a little bit larger than 0, so we're going to go ahead and just call it 1.25, comma 0.25. Okay? There's page 1. Okay, on this example, what you have happening is you have these two equations here, y equals x minus 4, and then 2x minus 2y is equal to 8. And so what we have, we don't have a graph, but we do have a table. Okay, we have a table for y equals x minus 4, and then a table for 2x minus 2y is equal to 8. So here's what we've got. What I'm going to do is I'm going to plug in these x values into my equation here and figure out what my y value is. So if I plug in 2, I'm going to do y is equal to negative 2 minus 4. Okay, so y is going to equal negative 6. So I have negative 6 here. Okay, if I plug in 0, all right, I'm going to do y is equal to 0 minus 4, which is going to equal negative 4. Okay, if I plug in 2, I'm going to get y is equal to 2 minus 4, which is going to give me negative 2. Okay, so these are just points on a graph. All right, now on the other one, okay, it's going to be a little bit harder to solve for y, and you can do this a number of ways, but we can say, all right, well, let's just do 2 times negative 2 minus 2y is equal to 8. All right, so that's going to give me negative 4 minus 2y is equal to 8. If I add 4 to both sides and solve this equation for y, then I get negative 2y is equal to 12. Divide by negative 2, divide by negative 2, and we get y equals negative 6. Oh, man. Check this out. We got the same point here. Okay? So negative 2, negative 6. All right, well, let's see what happens when we plug in 0. This will be a little bit easier. All right, so if I take 2 times 0 minus 2y, is that equal to 8? What do we get? Okay, so 2 times 0, that's just 0. So you get negative 2y is equal to 8. Divide by negative 2, divide by negative 2, and so y is equal to negative 4. Whoa, wait a minute. It's the same thing here. And it's the same thing here. All right, well, hold on. Let's try the last one. Okay. If I plug in 2 into that equation, okay, let me switch up my colors. If I do 2 times 2 minus 2y, will that give me, what do we get? What's y? Whatever. All right, 2 times 2 is 4. Minus 2y is equal to 8. So if I subtract 4 from both sides, then I get that negative 2y is equal to 4. Okay, divide by negative 2, divide by negative 2, and so y is equal to negative 2. So again, we get the same thing. Okay, negative 2. So the tables are the same. So if all of those points are all common, then we have an infinite solutions. Okay. Okay. All right. It says, which equations can pair with y equals 3x minus 2 to create a consistent and independent system? So if you look back at the previous page, when they talk about having a consistent and independent system, okay, we need to think about, okay, what does that mean? All right, put that in layman's terms. That means that you have one solution, okay? And so, the thing that I notice is that if we have no solution, okay, no solution means that the lines are parallel. Okay, which means that they have the same slope. All right. Now, if we go back over to this graph, we take a look at it, what I notice is that the slope of this line here is 3, correct? Okay, right here, if we notice the slope of that line is 3. So in this line here, I know that my slope is equal to 3. So what I want to do is I want to eliminate all of all of the lines that don't have a slope of 3. Okay, so I know here that this line here has a slope of 3. I'm going to get rid of that. That's not going to give me one solution. Okay. I do know here that my slope is m is equal to -3. So that will intersect it just once. Okay, so that one is good. Okay, that second one is good. X is equal to 3y minus 2. Well, let's take that and solve that for y. So let me rewrite that down here and say, let me do x is equal to 3y minus 2. If I add 2 to both sides, then I get x plus 2 is equal to 3y. Divide by 3, divide by 3, divide by 3. I get that y is equal to 1/3 x plus 2/3. All right, so that one has a slope of 1/3. M is equal to 1/3. All right, so we're looking for equations that don't have a slope of 3. So that one's good. Okay, let's take 6x minus 2y is equal to 4. Let's solve that for y. So I'm going to subtract 6x, so we get -2y is equal to -6x plus 4. Divide by -2, divide by -2, and divide by -2. We get y is equal to 3x minus 2. Notice how I have a slope of 3. Okay, so that's not going to have, I just want one solution out of this. It's actually the same line because you have the same y-intercept. This one will have an infinite number of solutions, so this one doesn't work. Okay, but let's check out this last one real quick, and let's just solve this for y. I'm going to add the x to both sides real quick, and so we get 3y is equal to x minus 2. Divide by 3, divide by 3, divide by 3. So you get y is equal to 1/3 x minus 2/3. Okay, so again, this one has a slope of 1/3. It's not the same slope, so this one works. Okay, so those 3 answers are the ones we're looking for. Okay, all right, let's go ahead and move on a little bit here. Okay, okay, the next part is a concept that we want to call linear systems of linear inequalities. So systems of linear inequalities. Let me just write it here. Inequality. Okay, and so basically, you have this equation here. You have two inequalities, okay? You have this line here, and you have this line here. And what we're trying to figure out is what values for x and y are going to satisfy the inequality, all right? So what that means, if I have this equation here, then, this is where in Algebra 2, the one where you shaded going this way, okay, above the line. And then you have this part here where you would shade below, okay? And we want to figure out where do we have a common shading ground, okay, is the idea. All right, that's what that picture means, okay? So where So the question we want to ask ourselves is, where does the shading overlap? Is the question I ask myself. Okay, and that's what we're going to explore here. Okay, so it says which is the graph of the system y is less than or equal to 3x plus 4, and y is less than 3x minus 2. So first of all, what we want to do is we want to take a look at this, and I'm just going to treat this equation like y equals 3x plus 4, and I'm going to treat this equation as y equals 3x minus 2. Okay, notice that we have the same slope in both of these equations. Okay, now this line has a y-intercept of 4, so it's going to correlate with this one. Okay, and then this graph has a y-intercept of negative 2. It's going to correlate here, and you can kind of see that written down here below each of these. Okay, and so what I want to do is I want to say, I want to test a point. Okay, I'm going to test a point. And the easiest point to test is the point 0, 0, the origin. Okay, x equals 0 and y equals 0. And if I do that, then I'm going to plug in 0, 0 into this graph here. Okay, or into that inequality. So I'm going to do I'm going to do this. I'm going to do 0 is less than or equal to 3 times 0 plus 4. Okay? If I evaluate this, I get that 0 is less than 0 plus 4, which is then just going to give me 0 is less than or equal to 4. And what I know is that 4 is larger than 0, so this is true. Okay? So what we would do is we would actually shade below this line. Okay, so here's this line. Wherever we have a true statement, wherever that point lies, depending on what side of the line it is, that's where we're going to shade. So we would shade down. We would shade down in this case. Okay, and notice that in this first example that they've shaded above. So what we want to do is we want to cross off A. That one doesn't even work. Okay, but now let's plug in 0, 0 and see if it works in the other equation. So let me do 0 is less than 3 times 0 minus 2. So we get 0 is less than 0 minus 2. 0 minus 2 is just going to be negative 2, so 0 is less than negative 2. Negative 2 is not larger than 0. This is false. Okay, so we would actually shade in this direction here. Okay, but what this has here, here it's saying that all right, so what we notice here, because that's false, we would shade below here. Okay, now what we see here is that here you see that there is shading below, but what this graph is saying is that these two shadings intersect, okay? So basically what they did is they did the same thing here and just made it look like they were intersecting. But here, okay, we're shaded below, all right, below that line, and then we shade below this line here, okay? And so the common area that we need to look for that is our solution is this area here, okay? Because that's where they both occur. So C is our right answer. Okay? All right, let's take a look at the next page. Okay, this next problem is kind of interesting. What we want to do is we want to decide whether each point is a solution to the system. So I'm just going to go ahead and plot these points, and I'm going to see what we get. So I'll plot the point 0, negative 2. Okay. Now this one satisfies this equation here. Okay, it's below this line. But the problem is that 0, negative 2 is actually on this dotted line. but we want to actually have that value somewhere in here that's below this line. Because it's on the line, it doesn't actually work. And let me show you algebraically why that happens. Okay, if I plug in negative 2 for y is less than 3 times 0, which is x minus 2, we get the statement of negative 2 is less than 0 minus 2. So I get negative 2 is less than negative 2. Okay, that's a false statement. Okay, negative 2 is not larger than itself. It's equal to itself. Okay, so no. That one doesn't work. No. All right, let's try the 0.50. Now 50 is right about here. Okay, now that falls below each of these lines, so we're good. Okay, we don't really have to do anything else. Okay, so this one is true. Yes. Okay. Okay, but if I do 313, okay, let's plug in 13 for y. Let's just plug it into the first one. Is less than or equal to 3 times 3 plus 4. So that's going to give me 13 is less than or equal to 9 plus 4. 9 plus 4 is 13, so 13 is less than or equal to 13. This is true. Okay, let's check it in this equation as well. Let's check it in 13 is less than 3 times 3 minus 2. 13 is less than 9 minus 2. 13 is less than 7. This is false. Okay, so it has to work for both of them. If it works for both of them, then we're good, but if it doesn't, then it doesn't. Okay, so this one, no. All right. All right, let's take a look at the next problem. What is the solution to the system shown here? Okay. All right, so for this one, we've got a y-intercept of 5 and an x-intercept of 5. And so if we draw this line here, oh man.
It actually says that one is wrong. The points on one side of one of the lines is wrong.
All right, so if I graph this, what I know is that x plus y, those values need to be larger, greater than or equal to 5. So I'm going to shade up this way, okay? And then if x plus y is less than or equal to 5, then we shade down. Now, the only place where they have common points is the actual line itself. Okay? And so that would be the points that are on the line. Okay? All right, let's take a look at this very, very last one. Okay, in this situation, Giselle has a job at the grocery store that pays $12 an hour and a job at the library that pays $9 an hour. She wants to earn at least $135 a week but work less than 15 hours. The system of linear inequalities shown represents the situation. So that's there, and then we have the graph, okay? What does the solution to the system represent? So, first of all, let's identify what x is and what y is, okay? X is attached to the 12, okay? It's next to the 12. That's the number of hours at the grocery store, okay? So x is equal to grocery store hours. Grocery hours. Okay. Y is attached to the 9, okay, so that is the library hours. Okay. So with that, okay, grocery store hours and the library hours, we want to make at least 135, if not more. But if we combine the number of hours that we work, we want that to be less than 15. So the solution is any combination of x and y values that work for this. Okay, so now if I plug in 0, and I'm going to test the origin, okay? If I plug in the origin into this equation here, or that inequality, I'm going to get 12 times 0 plus 9 times 0. Is that larger or equal to 135? Okay, the answer is no. Okay, we're saying that 0 is greater than or equal to 135. This is false. When I have a false statement, what I want to do is then shade up. Okay, so I'm going to shade above that line. Okay, above the blue line. Okay. All right, and then the next thing I want to do is I'm going to plug in 0, 0 into the bottom equation. So if I do 0 plus 0, is that less than 15? And the answer is yes, 0 is less than 15. This is true. So what I would do is I would shade the value that has that point, okay? So if I come in here, I would shade down below, and what we want to see is that where do they have a common shading ground, okay? And that common ground is that slice. Yeah, exactly right. And that little slice, any x and y value that's in between those two will give us the number of hours that we need, okay? So that's all I have for section 3. So hopefully you enjoyed these videos, and we'll get started on the homework.